Good afternoon. Welcome. My name is Sang Lee, and I'm going to be with you for the next 4 months with the topic of probability and statistics. So, this is the first lecture, and I'm going to introduce of this lecture, and I'm going to tell you a very fundamental concept of this probability theory in this time. So please enjoy it. The name of the course is Introduction to Probability and Statistics. So this course uh, provides an elementary introduction to probability and statistics with engineering applications. So you are engineers, so we have to learn some application related to civil engineering or environmental engineering. So the topic includes basic probability models, random variables, discrete and continuous probability distributions, statistical estimation and testing, confidence interval, and an introduction to linear regression and design of the experiment. So this part is mostly about the probability theory, and this part is about the statistical analysis based on the probability theory that you learned, and the final part is about some engineering applications. So you need to have some prerequisite such as calculus, such as the knowledge on calculus, engineering mathematics, and of course English. So the textbook is this one. It's Essentials of Probability and Statistics for Engineers and Scientists, and this was published in 2013. And of course, the lecture note is also important because it actually summarizes this textbook, the contents of this textbook. And what you have to know is there's a Korean version of this textbook. So if you want, you can buy this one, the Korean version, and you can just follow that. Of course, it may be a little bit confusing because I'll teach you in English and you have to study with the Korean textbook, but there's some pros and cons with that. So it's definitely your choice to buy whether you either this English version or Korean version. And there's some references that I'll bring you during this semester. This is about the grading. So the performance in the midterm test will take up 30% of the the grading, your credit, and final exam 40%, attendance 10%, assignments and quiz are just for 20%. So you need to follow this lecture, and you need to take a good result from this examination, and then you'll of course have a very good grades from this class. There's a meeting time, so mostly I'm available in Thursday morning, so you can just visit my office, which is located in the room 543 in the engineering building. But before you plan to visit, please contact me through email or this SMS so that I can confirm you. I can confirm that these meetings or interview. And this is the summary of this semester, the whole lecture. So this is the first lecture, and I'm going to tell you about the introduction of this lecture. And since this is the second week, in fact, in this semester, so I'm also going to introduce some fundamental aspect of the probability theory this time. And then we can move on to have advanced topics such as conditional probability, random variable distributions, and expectations. And in some engineering applications, it is also very important to learn some special distributions such as binomial distribution, normal distribution, Poisson distributions. So we'll learn something like that. So that part is mostly about the probability theory, and once you finish this one, we will take a midterm examination, and then we will move on to the part on the statistical analysis. So we'll learn the techniques for the estimation, sampling distribution of estimators, test of hypothesis, curve fitting, regression, design of experiments, and then we'll be ready for the final examination. The schedule for quiz and test are not determined yet, so I'll just arrange that during this semester. Before we start, we needed to clarify some of the things. The first thing, the lecture materials, they will be uploaded in the Cyber Campus site, Cyber Campus site, and I'll try to minimize the time for the cancellation of the lecture, but there will be some events that I cannot, that may be inevitable. So under that situation, I'll just let you know through this SMS. So please check your SMS regarding this lecture schedule. And when we miss the class and when we have this cancellation of the lecture, I'll try to have that. I try to have supplementary lecture through the online video lecture. So when we have that kind of situation, I'll just let you know how you can take this lecture and how to learn from that. So that's something that I'll let you know later. Another thing that I have to mention is there's the ethics in the class, so don't try to cheat during the test without any warnings. You'll just get the F or very bad credit when you try to do that. So that's something that you have to be very careful. And don't try to leave the classroom during the lecture. That is really disturbing. Although I'm not going to, prevent that, but that's something that you have to control yourself. Otherwise, that is not very good. So you may go to the restroom during the break unless you are really sick. If you are really sick, you have to leave the classroom during the lecture. But this is kind of this situation. So when you leave the classroom during the lecture, I'll presume that you are very sick. Otherwise, And please let me know if you need to leave the classroom early. And once you leave, don't come back. I mean, it's not very good to do that. And since this is an English lecture and you have to take some English lectures, so don't complain about the English lecture. Probability and statistics, this is a very difficult kind of this knowledge. So even if you get that in Korean, it's not really easy to take it. So it's not a very big problem if even if it's given in English. Online lectures video files are available through this website, and that's actually the lecture that I gave last year. And I think you don't want to take this, but if you are interested in taking this, just visit this site, and we have some online lectures, so you can just take it. You can just watch it. Okay, let's begin. The first thing before we start is to understand why we have to learn this one. If this is unnecessary, it's just like a killing time. But as you probably know, probability and statistics, they are very important in engineering part, not only in engineering situations but also in just everyday life. Probability and statistics are very important. So you have to understand the basic concept, and you have to understand how to use that, how to apply that for solving actual problems. And that's why you have to take this, you have to spend some time in this classroom, try to understand the lecture given by me. Suppose that you are in the restaurant and you order soup, and normally the soup in this restaurant is very delicious. But sometimes you may have very bad soup. Maybe it's not normally happen, but if you are really unlucky, you may have very bad soup. So every day in every situation, we always have some level of uncertainty. So yesterday the soup is delicious. Today the soup tastes bad. Tomorrow the soup may be delicious. And the role of statistist is to quantify this uncertainty. The role of probability theory and statistical analysis is to estimate when how much uncertainty that we have under a certain event. And that's why we need to learn this class. We have to deal with this uncertainty, otherwise you are just exposed to an unknown future. And as an engineer, you cannot accept that, so that's why we have to learn this one. So the situation is like that. As a statistic, you can just you can just tell them that, okay, for example, with 95% confidence that today's soup is delicious, with a level between 73% and 77%. So that's kind of the way that we can estimate the uncertainty, and that's kind of the way that you will learn in this semester. The statistical analysis allows statisticians to make a categorical statement with complete assurance about their level of uncertainty. So now you understand why we have to study this one. And the next step is, what are we going to learn? What do we have to learn? The first topic that you will learn in this semester, in this class, is the probability theory. And actually, the history of probability theory is this actually originates from the history of gambling, and many gamblers wanted to know the uncertainty of the games. So they persist mathematicians to estimate these uncertainties, and that's why the probability theory was established. So with the motivation of gambling, now we have a lot of sophisticated probability theories, and that's the things that you have to learn first. The second thing is descriptive statistics. And one of the very good example of descriptive statistics is the population census. In every 3 or 4 years, we have the population census to know how many people are living in Korea, how many people are working in a specific place, or living in a specific regions. So to get that kind of information, we have to collect all the data, all the information, and we have to process it to extract some meaningful knowledge. And that's the role of this descriptive statistics, and that's the second thing that you have to learn in this class. So descriptive statistics is applied when we can enumerate whole population. So this is a procedure used to summarize and describe the set of measurement. So we'll learn about these things later in detail, but at this moment you may need to have this kind of concept. So we count everything and we describe these things with some representative measures, and that's the descriptive statistics. Another thing that you have to learn, and this is also very important, is inferential statistics. Inferential statistics is used for quality control. So normally when you produce something from a factory, you cannot, examine everything. So you have to get some samples, small portion of this whole product, which is called the sample, and you have to examine that. And from the measurement of this sample, you have to infer some of the characteristics of the whole population, and that's so-called this inferential statistics. So this technique is used for quality control. In summary, inferential statistics is used when we cannot enumerate the whole population. It's not possible to examine the whole the total smartphones produced from a smartphone manufacturer. They may produce thousands or millions of the smartphone, and we cannot just examine everything. So we only have to examine very small portion, and that's the situation that we need this inferential statistics. So inferential statistics is a procedure used to draw conclusions or inferences about the population from information contained in the sample. So when we talk about these inferential statistics, these two terms are extremely important: population and sample. So before we start, we need to have these keywords in your mind: experimental unit, population, sample, descriptive statistics, and inferential statistics. Of course, we will talk about I'll explain the concept of these keywords later in detail, but at this moment when you already have that in your mind, you needed to remember these keywords because they are like very the essence keywords in this lecture. Okay, the introduction is over, and now we are getting more serious about studying this probability and statistics. So let's start with the chapter 1 in your textbook, which is about the introduction to statistics and probability. The first part is the overview, which is about statistical inference, samples, populations, and the role of probability. The keywords that I already mentioned will be explained in this part, and so you'll just review the reason why we have to study this probability and statistics. So the statistical methods are used everywhere, and that's why we have to learn this one. So it is used in all areas, including industry and in many engineering applications. Statistics aims at handling uncertainty and variation in data. So uncertainty is the reason why we have to learn probability theory. Variation is the reason why we have to study statistics. If there's no variation, we don't need to learn statistics. So the existence of variation is a very important starting point for this statistical analysis. So let's talk about the variation. There are kind of examples of these variations. When we consider the measurement, we can just imagine this variation. For example, does the measurement value match with the true value? Do the measured values change every time? So suppose that you are measuring the length of a bridge, and yesterday you measured that the length may be 1.1 kilometer. Today, when the other person measured that, the length may be 1.11 kilometer. We actually don't know which one is true because nobody knows the true value. The problem is every time you measure that or the other person measures that, there's a difference. And that's one of the examples of this variation. Another example of the variation is the effect of new medicine. So in a hospital, doctors are developing new medicine, and the problem of this medicine is it is effective for some people, but it's not effective for the other people. So that's why we get this treatment ratio of a new medicine. Suppose that it is 85%. The problem is, the question is, it is really reproducible. So even if it's 85%, I'm not so sure that this may be effective for the next patient. So that's kind of the situation that we have to handle these variations in reality. Let's talk about the definitions. In probability and statistics, a variable is a characteristic that changes or varies over time and or for different individuals or objects under consideration. On the other hand, the experimental units are items or objects on which measurements are taken. So the measurement in this case results when a variable is actually measured on an experimental unit. The population is the whole set of all possible measurements, and the sample is a subset of population. So in the previous example, when we measure the length of a bridge, the variable is the length. So it is expressed as kilometer or meter or miles, something like that. Experimental unit is the bridge. The measurement is the activity to measure the length of the bridge. The population is all the measurement data. So the measurement done today, yesterday, a few days ago, or a year ago, something like that. And the sample is a small portion of these all measurement data. Let's talk about the history of the statistics. Actually, the statistics is a word combining two words, state and arithmetic. The term statistics is ultimately derived from the New Latin statisticum, collegium, council of state, and the Italian word statista. It's hard to pronounce. And the German statistic first introduced by and originally designated the analysis of the data about the state, signifying the science of state, when and it acquired the meaning of the collection and classification of data generally in the early 19th century, and it was introduced to English in 1791 by the Sir Sinclair, and when he published the first of 21 volume titled The Statistical Account of Scotland. So the Sir Sinclair is actually the starter of this kind of part. So you can just see that this statistics was the techniques for the statistics was developed for some practical purposes. In ancient time, and even even now, this statistics is closely related to money. So in 18th centuries or 19th centuries, the accurate estimation of the population means the government can get more tax from the citizens. So statistics equals tax at that time. So that's why many statisticians try to develop techniques to have reliable data, and that's why the statistical techniques was rapidly developed at this time. I already mentioned that population and samples are very important concepts. So that's why I have to emphasize this. These are the ultimate goal of the statistics. To know exact information on population is actually the reason why we have to apply statistical analysis. As I mentioned that there are two kinds of statistics, descriptive statistics and inferential statistics. Descriptive statistics means it is the rearrangement and summary of sampled data, calculation of statistical graph, something like that. On the other hand, inferential statistics is includes methods for inferring parameters of the population from the statistic. So the meaning of this or statement will be discussed later. So at this moment, you just have to understand that population sample, they are very important. I like this picture a lot, so that's why I wanted to explain this. In fact, as I mentioned, the information of the population is the most important things that we want to know. Population is normally too large, so it is not easy to get this kind of information. So for example, the information of the population may be the average number of people or average level of income, something like that. And these are called the parameters. And there are two ways that we can get this information of the population, information on population. The first technique is the census, total enumeration, and the other one is sampling, examination of a small portion of this population. And this part is called as the descriptive statistics. When you have this measurement, we have to analyze the data, and from this analysis, we can get some useful information, which is called the inference. And this step is called as inferential statistics. And normally, when we examine these samples, we get some information on the samples, which is called a statistic. So parameter is the value, is the characteristic property of the population. Statistic is the properties of the sample. And the measurement part is the descriptive analysis, and interpretation part is the inferential statistics. Here we needed to have probability in addition to statistics. In fact, probability and statistics, they are closely related. Probability is an essential tool and language for statistics. The concept of probability is inevitable for collecting samples and doing statistical inference. So when you have this population, and when we get the samples, or when we measure some properties of the population, we needed to have some idea based on this probability theory. So from population to sample, we have to apply this probability theory. And from sample to population, we needed to have this statistical analysis, statistical technique called the inference. So it's like that. From population to sample, we need probability. And from sample to population, we needed to have this statistical inference. So this is the fundamental relationship between probability and inferential statistics. From now on, we'll take a look at some of the examples. The first example is about the manufacturing process. Suppose that an engineer encounters data from a manufacturing process in which 100 items are sampled and 10 are found to be defective. This is a typical problem of quality control. So when we get the sample and we can determine whether it is defective or non-defective, and based on this activity we can just infer how many products in this manufacturing process are defective. And that's the so-called quality control. So this is the first example. It is expected and anticipated that occasionally there will be defective items. Obviously, these 100 items represent a sample. However, it has been determined that in the long run, the company can only tolerate 5% defective in the process. Now, the element of probability allows the engineers to determine how conclusive the sample information is regarding the nature of the process. By having these samples, by examining the samples, the defective ratio is actually 10%. But the owner of the company wants to have the defective ratio of 5%. However, even if we have this defective ratio of 10% from the sample, it does not necessarily mean that this defective ratio of the whole population is 10%. It is tricky, but there are some relationship between this one and this one. In fact, this is the statistic, and this is the parameter. And anyway, later you'll learn what's the meaning of the information on sample, and how we can infer parameters using the statistic based on this statistical analysis. At this moment, what you have to remember is this kind of problem is very, very common in engineering situation and manufacturing situation. And that's why, again, the statistics is very important. If you look at this problem, when we have this 5% of defective ratio in this manufacturing process, there is a probability of less than 3% of obtaining 10 or more defective items in a random sample of 100 items from the process, which means it's not normally happen if this defective ratio is 5%. So definitely it looks like the defective ratio of this manufacturing process is over 5%. Clearly, it would occur with a much higher probability if the process defect ratio exceeded by a significant amount. This is the second example, and in this case, we are growing plants, and we are examining the effect of nitrogen on the growth of the plant. So we have two sets of this plant. The first one is the case without supplying any nitrogen, and the second one is the case with the supply of this nitrogen. And as you know, this nitrogen is a essential element in a fertilizer. So people can expect that this nitrogen will increase the growth rate of the plant. But we have to actually compare that experimentally, and that's why we have this kind of example. But the thing that you have to consider is when you grow plants, the growth rate is not constant. So some plants may grow slowly, and the other one may grow rapidly. So even if without supplying nitrogen or with supplying nitrogen, the growth rate changes. So we need to compare that like this. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plants for without supplying nitrogen, and 10 plants with supplying nitrogen, and we plot this growth rate in this kind of graph. So in some cases, the plants without nitrogen have higher growth rate than the plants with nitrogen, but mostly these are the plants with nitrogen. These are the plants with without nitrogen. So if you compare the whole set, you will see that this nitrogen effect is important. But how can we express the conclusion in the dot plot using scientific language? So in this case, again, we have to apply the concept of probability and the concept of a p-value, which we will talk about later. There are a lot of very good lectures to explain the concept of statistics. So one of them is the TED lecture, and during this semester, if I have time, I'll just let you watch this TED lecture because this is very informative and very nicely presented and much more helpful than my own lecture. The second part is about the sampling procedures, which is very important. In order to get information from the population, the sampling procedure is critical. So in this section, in this part, we'll learn how to get samples and how to collect data. It looks like the sampling is very simple, but it's not really simple at all. Suppose that you are selecting 5 representative students among this classroom. And these 5 students should represent the whole class. So it's not really easy to select which student. That's why this sampling procedure is complicated. And people have learned that, studied that, and the conclusion is the simple random sampling is the most effective. This is a sampling method where the probability to select a certain sample is the same. So in order to do that, we needed to use random number tables or other tools. So when we select sample, we should not have any prerequisite ideas. So for example, if I choose some student, the probability to choose the student should be equal. Otherwise, the sampling is not really effective. So we have to avoid biased sample, and and that will represent population. So this random sampling is important, especially when we consider opinion polls for president's election or the senator elections. Sometimes we need to apply a special technique called the stratified sampling, and in this case the sample units are not uniform and strata is formed. So for example, we can just have the samples from each population line, and that makes sense in some cases. So that's there are a lot of ideas that we can get sample from the population. This is an example of the random number table, just for your information. There are a lot of historical events that shows the importance of the random sample and the problem of the biased sample. One of them is this the literary digest accident. I don't know what I can just say, but this is the case with the literary digest, which is the best remembered today for the circumstance of the surrounding its demise. And as it had done in 1920, 1924, 1928, 1932, it conducted a straw poll regarding the likely outcome of the 1936 presidential election. Before 1936, it had always correctly predicted the winner. But the 1936 poll showed that this Republican candidate, Governor Alfred Landon of Kansas, was likely to be the overwhelming winner over Franklin Theodore Roosevelt. But the result was opposite. We know that at that presidential election, the Roosevelt was elected. And that's why at that time people get this biased sample for these opinion polls. Here we have to learn the concept of experimental design. Experiment design. This is the structured method to know the effect of treatment. In the previous examples, we talk about this nitrogen effect and that kind of thing should be analyzed using some structured method, which is called the experiment design. In this case, the variation is analyzed by two terms, by treatment and by accident. So in the nitrogen effect, there are two variations. The first variation was caused by the nitrogen treatment, and the second variation was caused by accident. Inherent difference among the plants. Experimental methods are designed to have uniform variation in the group, random allocation, blocking, or other means. In this example, we'll see an example of design of experiment. A corrosion study was made in order to determine whether the coating on aluminum metal with a corrosion retardation substance reduced the amount of corrosion. So sometimes we needed to cover of this metal surface with special chemical to prevent corrosion, and the effectiveness of this coating layer may be experimentally determined. This example is just for that. And here, to measure the effect of the coating, there are two groups. The first group is the uncoated metals, and the second one is the chemical corrosion coating metals. But here we have two situations with different humidity. So humidity 20% is a very dry day. Humidity 80% is a rainy day with some moistures. And of course, with this high humidity, this corrosion will be accelerated. So that we need to compare that. And by comparing this, the average corrosion in thousands of cycles to failure was like that. So of course this number are higher for the chemical corrosion groups compared with the uncoated groups, which means this corrosion is the coating is effective. So in this case, what you can see is there are two variables that we consider, two conditions that we consider in this example. The first condition is the coating, and the second condition is the humidity. And the result or outcome is the average corrosion in thousands of cycles to failure. So that's one of the examples that you may face with in engineering situations. If we draw a picture, draw a graph, we can see like that. So this coating is effective at under low humidity condition, but it is more effective under high humidity conditions. So that's the conclusion. That's the summary of the experiments done in the previous page. In this section, we will study the concept of discrete and continuous data. In fact, there are two kinds of quantitative data. One of them is discrete, and the other one is the continuous. Discrete data is countable. So number of people, number of defective products, they are all the examples of the discrete data. On the other hand, continuous data is non-countable. So for example, weight, height, ratio of defective products, they are all non-countable and continuous data. In some cases, we have special data called binary data, 1 or 0, yes or no, pass or fail, and it's used to calculate the sample ratio. In order to understand the probability concept, you also need to understand the concept of sample space and events. So we'll talk about this here. There are some of the definitions and terms. Statistical experiment is the activity to create data. For example, when you toss a dice or when you measure a weight, it is all classified as a statistical experiment. And by doing that, we can create sample space, which is defined as like this. The set of all possible outcomes of a statistical experiment is called the sample space and is represented by the symbol S. So as a result of these statistical experiments, we can create data and that's sample space. So each result of the sample space is called the sample point. So for example, when you toss a dice, the sample space is 1, 2, 3, 4, 5, 6, and sample point or element is either 1 or 2 or 3 or 4 or 5 or 6. In this example, we can review the concept of the sample space and the element. Suppose that we are doing the experiment of tossing a dice, and the sample space is, of course, as I mentioned, that the number starting from 1 to 6. But with the same experiment, when we change the point of view, we may have different sample space. For example, if we are interested only in whether the number is even or odd, the sample space is simply even, odd. So, with the same experiment, by having different interest, we can create different samples. The sample space may be different even in the same experiment depending on the interest. This is an example of the tree diagram. Suppose that we have 3 items. We select 3 items as random from a manufacturing process, and we can denote the defective items D and non-defective items N. And since we select 3 items, the sample space should be like that. So the first one is defective, second one is defective, third one is defective, that's DDD. And with the similar manner, we can have other element like DDN, something like that, and all possible outcomes is the sample space, and that's this one. One of the best way to have this sample point and sample space is to draw this tree diagram. So we have 3 items, and each item have different possibilities, and by listing all the possibilities, we can have all possible outcomes. And by drawing this kind of tree diagram, we can have a structured way to create sample space. Sample space with a large or infinite number of sample points are best described by a statement or rule method. For example, if we have this sample space with million elements or million sample points, it's not possible to list all of them. Instead, we can just mention the rule to describe this sample point. Here are examples. In the first case, the rule is given by that the X is a city with a population over 1 million. There may be 10 or 20 cities all around the world, and that's all included in this sample space. In the similar manners, we can just define the sample space by the description. Another important concept is the event. An event is a subset of a sample space. The concept of event is clear by looking at this example. Given the sample space S is this one, as a subset of this sample space, we can define the event like that. So just you can imagine that the small part of this, the sample space, can be defined by an event. And there are 2 different kinds of events. For example, if there's nothing, we can just say that this event is a null set. So and null set means there's no element in the event, and the entire sample space can be also an event. Again, we can have some of the concept. The complement of an event A with respect to S is the subset of all elements of S that are not in A. We denote the complement A by the symbol A dash. So if you look at this example, consider the sample space of S that includes book, cell phone, MP3, paper, stationery, laptop, and if the event is book, stationery, laptop, and paper, and the complement of A should be cell phone and MP3, which are not included in this event. But one thing that you may pay attention here is the concept of mutually exclusive or disjoint. And the definition is like that. Two events, A and B, are mutually exclusive or disjoint if the intersection of A and B equals the null event. That is, if A and B have no elements in common. So there is another examples, but it's clear that you can understand that without after just reading and following this example. So I will not give you any more explanation. The union of two events A and B is the event containing all the elements that belong to A or B or both. So if A is ABC and B is BCDE, then the union of A and B is ABCDE. Again, it's in this section, we'll study how to count sample point. There are two techniques that you have to remember. The first one is permutation. A permutation is an arrangement of all or part of a set of objects. And consider the three letter A and A, B, and C. The possible permutation are ABC, ACB, ABAC, BCA, CAB, and CBA. So we can have 6 distinct arrangements. The number of permutation of n object is n factorial. In general, the number of permutation of n distinct objects taken r at a time is denoted as npr, and this is n factorial divided by n minus all factorial. So if you look at this example, here, 3 awards, research, teaching, and service will be given to a class of 25 graduate students in a statistics department. If each student can receive at most one award, how many possible selections are there? So we have 25 students and we have 3 allocations. So that's 25p3, and so 25 factorial divided by 22 factorial. So the all possible selections are, the number of all possible selections are 13,800. In this example, a president and a treasurer are to be chosen from a student club containing 50 people. How many possible choices of officers are possible if there are no restrictions, or A will serve only if it is present. So there are a lot of conditions, and in each case we can just consider and all the possible restrictions and cases. So for example, in the first case, if there's no restrictions, we have 50 students and 2 locations, so that's 50 P2. So all possible arrangements are 2,450. You can study the remaining part by yourself. There is a variation of permutation. One of them is circular permutation. The number of permutation of n object in a circle is n minus 1 factorial. So it's clear that if we have the circular arrangement, for example, 5 if we have 5 chairs arranged just like that, though the circular permutation is 4 factorial based on this definition. The number of distinct permutation of n object of which n1 are of one kind, n2 of a second kind, blah blah blah. And in this case, there are same object in the permutation procedures, so we have to consider that. And in this case, we can just calculate the all possible arrangement by having n factorial divided by n minus 1 factorial and 2 factorial and n1 factorial, n2 factorial, and nk factorial. So for example, in a college football training session, the defensive coordinator needs to have 10 players standing in a row. Among these 10 players, there are 1 freshman, 2 sophomores, and 4 juniors, and 3 seniors. And so there are same people in a group, same groups among these 4 different groups in these 10 players. So in this case, the way that we can just arrange this is 10 factorial divided by 1 factorial, 2 factorial, 4 factorial, and 3 factorial, and the result is approximately 12,000. Another variation is partition. The number of ways of partitioning a set of n objects into R cells with n1 elements in the first cell and 2 elements in the second, and so forth, is given by this one. So, for example, how many ways can 7 graduate students to be assigned to 1 triple and 2 double hotel rooms during a conference? So we only have 2 rooms. 1 room have 3 bed, and 2 room has 2 bed, and we total have 7 students. So we have to allocate the student to each room. So in this case, we call this procedure as partitioning, and we can denote that. Again, we can calculate, which is very similar, the way that is similar to the previous calculation. 7 factorial, 3 factorial, 2 factorial, 2 factorial, which is 210. So this is the first method. And the second method to count count samples is combination. The number of combination of n distinct objects taken all at a time is n all, which is n factorial divided by r factorial divided by n minus r factorial. So the difference between permutation and combination is, in case of combination, we don't consider any order. So we select all from n, but we don't care the order. The concept is clear by looking at this example. A young boy asks his mom to get 5 Game Boy cartridges from his collections of 10 arcade and 5 sports game cartridges. How many ways are there that his mom can get 3 arcade and 2 sports game cartridges? The method of way of selecting 3 cartridges from 10 is 10 3, and this is 10 factorial divided by 3 factorial and 7 factorial. The number of ways of selecting 2 cartridges from 5 is 10. So the total, the possibility is 120 multiplied by 10, which is 1,200 ways. So as you can see that there's no order. So that's the clear difference between permutation and combination. In this example, we wanted to know how many different letters arrangements can be made from the letters in the word statistics. So in this word statistics, there are 3S, 3T, 2I, 1A, and 1C. So it's like that we select that without any order. So 10 factorial, 3 factorial, divided by 3 factorial, 3 factorial, 2 factorial. So the possible arrangements are about 50,000. Now it's time to talk about the probability of an event. The concept of probability started in 17th century, probably from Pascal and Fermat. And this probability theory was almost completed by many famous mathematicians and statisticians, such as Kolmogorov. You can see the picture of these guys, these famous people. Anyway, the definition of probability is that the probability of an event A is the sum of the weights of all sample points in A. Therefore, PA, which is the way that we denote the probability of an event A, and PA is always between 0 and 1, and then the probability for a null event is 0, and probability of a sample space is 1. Moreover, if A1, A2, A3 are mutually exclusive, the probability of the union of these events is equal to the sum of individual probability. So PA union A1 union A2 union A3 union equals PA plus PA1 plus PA2 plus PA3. So here we have the first example about the probability. a coin is tossed twice, what is the probability that at least one head occurs? In order to get the answer, we first have to construct the sample space. The sample space is HH, HT, TH, TT. Of course, H is head, T is tail. And the event that we are interested in is the includes at least one head, so HH, HT, and TH. So the probability is actually the sum of individual mutually exclusive ones. So the probability is 3/4. In a similar matters, we can also calculate the probability in a dice toss experiment. In this case, a dice was tossed, and the event that we are interested in is that a number less than 4 occurs on a single toss of the dice. So the sample space is 1, 2, 3, 4, 5, 6, and the event is 1, 2, 3. But in this case, what you have to be careful is the weight. In this case, this dice is a strange one, so that an even number is twice as likely to occur as an odd number. So this is called the weighting factor. So you can see that by considering the weight, the probability is not 0.5, instead is this one due to this weight. If an experiment can result in any one of n different equally likely outcomes, and if exactly n of these outcomes corresponds to event A, then the probability of event A equals n divided by large N. So that's the definition. So that's all of which are equally likely to occur. So this is the fundamental method to calculate the probability. As an example, we will take a look at this one. A statistics class for engineers consists of 25 industrial, 10 mechanical, and 10 electrical, and 8 civil engineering students. If a person is randomly selected by the instructor to answer a question, find the probability that the student chosen is A, an industrial engineering major, and B, a civil engineering or an electrical engineering major. The first question is very simple. We have total 53, and the number of this student in industrial engineering department is 25. So the probability for the first case is this one, because these are all equally likely to happen. The second one, we just test the union. So since the sum of the student from civil engineering and electrical engineering is 18, so this is the 18 divided by 15/3, and this is actually the union of C and E.